Here we are at example 8 from the 0.2 number 27 notes. We're asked to graph this following rational function. Let's go ahead and start out by factoring. It's best to get kind of in that habit to see if anything might potentially cancel. We notice we can pull an x out of the top, and we're then left with x minus 1. On the bottom, we can't unfortunately factor anything, so we still have that x plus 1. Now, we're going to go ahead and find out maybe what are our vertical asymptotes. And so we accomplish that by just simply setting the bottom not equal to 0. So for our VA, we have x plus 1 is not equal to 0. And then we just solve. So when we just subtract 1, we see that x is not equal to negative 1. So we should end up with a vertical asymptote at negative 1. X equals negative 1. Now let's go ahead and discuss the horizontal asymptote. Well, here we see that the top degree is larger than the bottom, and as a result, we actually won't have a horizontal asymptote. Because then we are in that scenario 3 where the top is larger than the bottom. Moving on then to our slant asymptote. Well, we notice that the degree is 1 more than the degree on the top is at least 1 more than the degree on the bottom. And we can also see that the bottom is in fact a linear that we're dividing it by. And as a result, we can then go ahead and use synthetic division. We're going to go ahead and place the opposite sign of this value, so it's negative 1. We're going to go ahead and place that in the box. For the other values, we're going to go ahead and place those coefficients. So we have 1, negative 1, and believe it or not, there really is a constant over here. It just happens to be plus 0. But that plus 0 actually does play an important role as we're doing our synthetic division. So we have 1, negative 1, and 0, just those coefficients in front. We leave ourselves some space, draw a bar, and then perform our synthetic division. The first number we just go ahead and drop down. And then the number in the box with this number underneath the bar, we're going to go ahead and multiply those. So negative 1 times positive 1 gives us negative 1. And we go ahead and place that right underneath the number that's following it. Now we're going to go ahead and add going down. So negative 1 minus 1 gives us negative 2. And then we just repeat the exact same process. So negative 1 times negative 2 is positive 2. We place that right under the next number, and then just add going down. So 0 plus 2 just gives us 2. Now because we had an x squared term, we divided it by a power of x. Essentially, we're removing this power down by 1. So as a result, before, since it was x squared, now it's actually going to end up coming out to be just x to the 1. Really, because this is minus 2, we have minus 2. And this last 2 over here is just our remainder. So the remainders, when we do our synthetic division, they don't really play too much of a role. So we can kind of just omit those. And as a result, our slant asymptote just comes out to be y is equal to 1x minus 2. So our slant asymptote has a y-intercept of negative 2 and goes up 1 over 1, has that slope of 1. So we should see something like this. Now let's go ahead then and move on to our x-intercepts. So we're trying to determine where is it crossing this x-axis. Well, if we know that it's crossing this x-axis, our y values are always going to be 0. We're not going up or down any. And as a result, this f of x, which is the same thing as saying y, we can go ahead and plug in 0 for y, because again, we're not going up or down any. So when we're trying to find our x-intercepts, we determine we're going to go ahead and plug in 0 for y is equal to x squared minus x all over x plus 1. Now, again, back to that little quick shortcut with finding x-intercepts, really we don't even care about the bottom at all. So now we're just going ahead and solving for this top piece for our rational function. We've already gone ahead and factored. And now using that zero product property, we can break each of these up. So this x is equal to 0, and this x minus 1 is equal to 0. This guy's already solved for. This one you would just have to add 1 to both sides. So we end up with x equaling 0 and x equaling 1. Now, it's really critical, though, that you realize that these are not your actual final solutions for x-intercepts. These are, in fact, lines. To determine an x-intercept, it's actually a specific point. So our points that are happening, at least our x values, include 0, comma, again, y value we determined was from before always 0. So for your x-intercepts, your y value will always be 0. For this one, we end up with 1, comma, 0. These are actually our x-intercepts. So on our graph, we should see a point here and a point here. Now let's go ahead and determine maybe some of the other values that kind of make up and comprise our graph here. So we have our x and our y. Selecting some values to the left, we have like -2, -3, -4. And some to the right would include, for example, 2 and 3. So these are to the left, these ones are our right. If you go ahead and plug in -2, you should end up with a y value of -6. When you plug in -3, you get -6, and -4, you end up with -20 over 3, which pretty much just comes out to be -6 and 2/3. When you try plugging in 2, you end up with 2/3. And when you plug in 3, you should end up with 3/2. Going ahead now and graphing these, we have -2, -6, which is right here. At -7, we have -6 as well. I'm sorry, -3, we have -6. And then at -4, we have -6 and 2/3. So we can see that it's below this slant asymptote and to the left of this vertical asymptote. So on the left side, you would see that hugging, and maybe it goes up a little bit and comes back down around. On the right side, we have our points 2, 3, or 2/3. So 2, 2/3, which is just a little bit above that blue slant asymptote. And then 3, 1 1/2. So we can see that it's, again, to the right of this vertical asymptote and above that slant asymptote. So we should see an image doing something like this. Example number 8 from the 0.2 number 2 set of notes.